Okay, today has turned into one of those disaster days. I sincerely apologize for not being able to come to class. Believe me, I much rather teach in a classroom because my camcorder just broke. I have a sick child, and my other 3 children who are technologically proficient are not here to help me. So, you are truly my guinea pigs. I'm attempting to record this through my phone and upload to YouTube. Wish me luck. You absolutely must print the notes. You're not going to be able to see them clearly enough through the video. The only reason I have them up is to be able to point to things. Now luckily we started sampling distributions last time, and we even did a full problem. About 48% of people were going to vote for a candidate. What was the probability? We found greater than 50%, etc. Last time we also discovered what the mean and the standard deviation of p-hat was, and we have both of our criteria. We always have to check for normality. I've written 15 here. We talked about last time you could also use 10. So let's do another problem. And through this problem, I'm trying to do a couple of differently worded questions that I know that you will see on your homework assignment. So let's say a chromosome defect occurs in 1 out of 200 people. A random sample will be taken. But sometimes in real life, especially if something's rare, and 1 out of 200 is pretty rare, we need to make sure we're going to take a big enough sample. We don't want to take too much because of time and money. So the first question we're going to ask is, what's the smallest sample size we have to actually take to make sure p-hat is normal? Well, you're going to use the normality criteria, but in a backwards way, actually using algebra to solve for n. Now, that 1 out of 200 is the true population, which is 0.005 in decimal form. So I put in a p of 0.005 here, and over here 1 minus 0.005. You divide both sides using algebra, you'll get an n of 3,000 and an n of 15.78. Now it's kind of tricky because it says what's the smallest n. You might think you could use 15 or 16, but remember, both of these formulas have to hold. And if you put in 15 here, it's going to work. But if you put in 15 or 16 over here times 0.005, that's not going to work. So you actually have to go with the largest of your 2 answers. So that's the rule. You're always going to pick the largest, and if it happens to be any decimal, you have to make sure that you round upwards. So for our part A, the answer is at least 3,000 needs to be in our sample. Now we're going to ask a question. This is a little bit harder of a question than what we did last time. What is the probability the sample proportion will be within 0.001 of the population proportion? And we are assuming we're going to take a sample of 3,000. That makes our life easy because we know we have normality because we had already checked in part A, and 3,000 gives us normality. So I don't need to check those formulas again. I do need to go ahead and figure out, well, I know what the mean is. The mean of p-hat is always the population proportion, 0.005. You need to go ahead and calculate the standard deviation term. And again, make sure you keep lots of decimals because that standard deviation is tiny. Also remember those formulas are on your cheat sheet. already realizing how pitiful a recorder I am, so I do apologize. So this one said within 0.001 of the population proportion. What is the population proportion? The population proportion was 0.005. And remember, our language, even when we were doing the empirical rule, that within means to jump up and jump down. So there's my population proportion. I'm going to subtract 0.001 from it. I'm going to add 0.001 to it. So really, the original question is asking us, what's the probability my p hat is between 0.004 and 0.006? Now I can turn p hats into z's like I've always done. I subtract the mean, divide by standard deviation on both of those. This is our basic stuck in between problem. You should get basically symmetry, the negative 0.78 and the 0.78. Those are z-scores. When you look those up to get the area, you'll get 0.7823 minus 0.2177 equals 0.5646. The within problems are the hardest. I know there's another one on handout 9. I think it's number 8, and then also number 2. The 2 problems we just did will definitely help you do those harder problems. Now, you absolutely want to make sure that you practice all of handout 9, numbers 1 through 8. Part of the problem with sampling distributions is now that we have done both types, for the X bar and for the p hat, when you read a problem, the very first thing you're going to have to do is decide, is this an X bar problem or is it a p hat problem? And that can give students a bit of a hard time. That's why you want to practice 1 through 8 all together. If you do book problems, you can do 6.4. These are the problems that will cause you the most trouble on test 3. I'm just giving you the heads up. Our next topic is the easiest. And I'm going to remind you at the bottom of the cheat sheet, very bottom, those are the formulas for the sampling distributions, but you do also have to memorize the normality criteria.